Okay, hey guys. For a little practice, we're gonna go ahead and bang out a random LeetCode question. So let's hit the random button and see what we get. Hopefully it's a good one. We've got 809 expressive words, and I have not done this one before. Sometimes people repeat letters to represent extra feeling. For example, hello goes to hello, and hi goes to hi. You're given a string S and an array of query string words. The query word is stretchy if you can be made to equal S by running any number of applications of the following extension operation. Here's a group and add some number of characteristics to the group. So the size of the group is 3 or more. For example, starting with hello, we give an extension of the group O to get hello. But we cannot get hello since OO has less than size 3. Blah, 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 blah. Okay. So how are we going to do this? I think we are going to basically make a little thing that's going to count. It's going to have like the character and the count of those characters in a row. So we're going to start by doing that for S. So for example, for hello, it's going to become something like H1, E1, L2, O1. And then for each of our words, we're going to basically start building the same thing. If we hit a character, and as we build it, we're going to compare with our word. If we hit a character that's not in our word, that's an immediate failure. Break the or continue the loop on to the next word. If we hit a character that's less than our desired count, then we can say if the desired count is greater than or equal to 3, we can add characters to make it work. Right? So I don't think there's any crazy algorithm other than working through things one by one. So first we'll start with target char counts, merge character in string. If character equals the previous, current count plus equals 1. Else previous is not done. Target char counts append previous current count. Let's make sure. Okay, it's gonna have to exist. Can't be 0 length. And then we're gonna go ahead and do that for the very last character, because that one otherwise will be skipped. And let's just make sure that is gonna work. Yeah, so we've got HE L203, 5 Z's, 4 Y's. What if we make one more test case that has a repeat character? Just to make sure they're separate. Yeah, H. Okay. Okay. So we're happy with that. Now we're basically going to follow similar logic here. For word in words, we're going to sort of do the same character counts, but we're going to go ahead and break. I mean, one way to do this actually would be to abstract this out into a function. The way that I was imagining it, we could do early returns for like a very micro, what do you call it, micro optimization. It would not improve the big O runtime, but it would be able to break on a word early if we already know that word's bad. I think I'm going to keep following that. Anyway, so for word in words, we're going to say I'm just going to copy this for a second. So this is the part that's going to be different. I always forget if it's index that comes first or the character that comes first. You know what? We actually don't even want that. You know what? I'm thinking about just going back to my function approach. I think that's so much cleaner. Equals. count. Or no, I in range lang word counts. Target count equals target counts I if word count 0 not equal to target count 0. Is stretchy equals false. And we're going to break. If word count 1 is greater than target count 1, or I'm just gonna break this into cases. Stretchy equals false and break. If word count 1 is less than target count 1 and target count 1 is less than 3, is stretchy is false. Break is stretchy count equals 1. Okay. I don't love this little thing, but I think it's clear enough. Name S is not defined. I don't know why I saved. We missed a parentheses there. We seem to have a problem with this one. Let's just print a little debug info, see if we can track down the bug. I know there's a bug here. And I'm pretty sure it's in this section here. Right, valid pair, valid pair, valid pair, valid pair, that's fine. What's going on here? Why does it say valid word? We just said can't make. Oh. Dumbest. Okay, we just had a typo. Sad, but we used our print statements to figure it out. And just reorganize a little bit here. The way that I like to have it. Take out my print statements. And we're passing everything, so let's go ahead and submit. Boom, not bad. Let's think about our time and space complexity real quick. So basically for every string, we're making the character counts. That's like O of M, where M is the string length. We're doing that one time for the initial string, and then N times, where N is the length of the words. And then we're comparing these, and that's going to be another O of M, which is 1 for each, which is the length of the character count, which could be the length of the string if all the characters are unique. So we're going to say time is O of M times N, where M is the length of the string and N is the number of words. And for space, we're going to say we're going to say basically the same thing. Because we're using that amount of space. We're using M space for each word. Multiply that by N words, you're going to get that. I think you could sort of space optimize it. You don't have to hold on to this. If I did it how I was sort of originally doing it, where I was going to go one by one through the words and have like an early return as I'm creating the character count, that would bring the space down to M times 1, where M is the length of S. So that could be done if you're really worried about space. Time would not be brought down by that. In terms of worst case, it could be brought down in terms of like average case if we had some earlier returns as we're making the character counts. But I'm pretty happy with that. I already submitted it. I don't know what I'm doing here. I can see what it says for S plus N times W. Makes sense. It's going to be, they're including the length of the string. I guess that's fair. I was just kind of assuming W and N, which I called M and N, would be dominant, but that's fine. I'm going to check out the editorial. They're using run length encoding, basically the same thing. They just did the key and the count in two separate things, whereas I did it in one array of tuples. But all right, it's fun practice. Thanks for watching. If you watched, it really was more for me, but I'm gonna go ahead and sign off.